Ladies and gentlemen, it's a pleasure to be able to speak to you. I will, in a very short presentation, introduce you to Recupera and what we do. Please bear with me. I will start to share the screen. Just to get the presentation rolling. 1 second, please. And then I need to laser. So, as I said, my name is Flavio Ortegal. I am the CTO and one of the founders of Recupera. Recupera has developed during many years a technology of low temperature conversion of carbonaceous material into syngas. We are at technology readiness level 6, which means our technology is already validated. We did that 2017 at our plant in Celje, Slovenia. We have now international projects, several projects at different stage of development. And these are my contacts. And so what we do, Recupera, we consider plastics as solid hydrogen carrier. This is as simple as disruptive insight. It is simple because, of course, plastics are hydrocarbons. They are derived from hydrocarbons. You see here some examples of plastics we can process. And of course, there are some plastics that are only carbon and hydrogen. Then there are plastics which have some heteroatoms. And there are plastics like PU, like PET, which have many different heteroatoms. But nevertheless, our equipment is capable of processing all of them. So we consider waste plastics as solid organic carriers of hydrogen. This insight is innovative and disruptive. It solves the problem of waste plastics. How we do? Well, we shredded the plastics to very fine particles, and then we run into our proprietary gasification equipment, and is 1 ton per hour, one ton per hour, and with that we produce around 2,500 cubic meters per hour of syngas. And syngas, of course, you have the possibility to do all the chemistry, but one of the simplest process is just the separation of syngas. Syngas, by definition, is a gas composed solely of carbon monoxide and hydrogen. Hydrogen and carbon monoxide in the relation 2:1, which happens to be what you find in polyolefin plastics. So it's not a surprise. Our gasifier has some technicalities that guarantee a very high quality of the syngas, of the produced syngas. This is important when you want to do chemistry, and this is what we want to do. One chemical process, very simple, and this is the low-hanging fruit, is just the separation of syngas. Then you have hydrogen and carbon monoxide, 2 gas streams. Hydrogen, of course, is sent to hydrogenation, desulfurization, metal reduction, decarbonization. This is the word that everybody is having now, speaking now. And of course, you can convert in fuels and you can use for energy storage. What can you do with CO? You can send it to methanol synthesis. And from methanol, you have, of course, whole chemistry at your disposal. You can also use CO in addition to syngas, and of course, you can use it as a thermal energy. But if you burn the CO, then you will produce CO2. Now, if you don't want to burn the gas, you don't want to produce CO2, you don't want to burn the gas, you can send for chemical synthesis. And this is the chemical recyclability of plastics. We are at the core of the circular economy of plastics. This is our equipment as it stands in Celje. Here you see a feed hopper. then it sees a screw here. These are the two towers. Whatever is not completely gasified, these towers are in X, is connected in series, but you have here, you can see only one. There are two of these cyclones, and there are, this is a 10-meter towers with 9 segments, each one. These segments you can see as a serial arrangement of gasifiers. In this case, we will have 18 gasifiers in series. Why we do that? To spend the money? Of course not. We do that to guarantee the highest quality of the gas. So the gas, which is completely gasified, it's go here, and then you have here a catalytic purification device to remove any impurity. And the pure gas then is separated and sent directly in the pipes of the client. This equipment has the footprint of a maritime container, so it's a very small footprint, and it processes 1 ton per hour of plastics material. With that, we produce 144 kilos per hour of pure hydrogen. So this is everything I want to talk to you in the moment. If you have any questions, please do not hesitate in contacting me. Thank you so much.